Ever pondered what's beyond the sky? What's out there in the vast expanse of the universe? There's something incredibly captivating about the cosmos, a mystery that has intrigued humans for centuries. From the explosive beginnings of the Big Bang to the formation of galaxies, stars, planets, and the world as we know it today, it's a journey of unimaginable scale, a cosmic ballet of matter, energy, time, and space. So, buckle up as we unravel the cosmic journey from the inception of the universe to the present day. Imagine everything that exists, compressed into an infinitesimally small point. That's the Big Bang for you. Now let's take a step back, shall we? It's about 13.8 billion years ago. All the energy, matter, space, and time in the universe is condensed into a singularity, a point of infinite density and temperature. It's so small, so hot, so dense that our current understanding of physics can't quite grasp it. But then something extraordinary happens. This singularity starts expanding. Not at a snail's pace, oh no. We're talking faster than the speed of light. In a fraction of a second, the universe balloons from the size of a proton to a grapefruit. It's a phase we call cosmic inflation, and it's still a bit of a mystery to us. As the universe expands, it cools down. Energy converts into particles and antiparticles, matter and antimatter. They annihilate each other, but not perfectly. For every billion pairs, one particle of matter survives. And those survivors, they're the seeds for everything we see in the universe today. But it doesn't stop there. This matter starts forming protons and neutrons, the building blocks of atomic nuclei. After about 3 minutes, the universe cools down enough for these nuclei to capture electrons. And voila, we have the first atoms, mostly hydrogen and helium. The stage is set for the formation of stars, galaxies, planets, and well, everything else. So to sum it up, the Big Bang Theory is our best explanation for how the universe began. It's not just an explosion, but an expansion of space itself. From a fiery, dense singularity to an ever-expanding, ever-cooling cosmos filled with galaxies, stars, and planets. And remember, all this happened in less than a blink of an eye on the cosmic timescale. It's a testament to the power and mystery of the universe, and our ongoing quest to understand it. In a fraction of a second, our universe went from a tiny point to an ever-expanding cosmos. As the universe cooled and expanded, matter began to clump together, giving birth to galaxies. Galaxies, dazzling tapestries of stars, gas, dust, and dark matter, didn't just pop into existence. They were born out of the cosmic dust, from the tiny fluctuations in the density of matter in the early universe. As the universe expanded and cooled, these minuscule variations in density grew, drawing in ever more matter through the inexorable pull of gravity. Over eons, these clumps of matter became denser and denser until they collapsed under their own weight, forming the first stars. These stars weren't like the ones we see today. They were massive and short-lived, burning through their fuel at a furious pace and ending their lives in violent supernova explosions. These explosions seeded the surrounding space with heavier elements, the building blocks of planets and life as we know it. But what about our own galaxy, the Milky Way? It's thought to have formed roughly 10 billion years ago in the aftermath of the Big Bang. Like other galaxies, it began as a vast cloud of gas and dust, slowly collapsing under the force of gravity. Over billions of years, this gas and dust formed stars, which in turn gathered into clusters. These clusters then merged, creating larger and larger structures, until they eventually formed the spiral galaxy we call home. Throughout this process, the Milky Way absorbed smaller galaxies, growing larger and more complex. Even now, our galaxy continues to evolve, with new stars being born and old ones dying every day. And in about 4 billion years, the Milky Way is set to collide with the Andromeda Galaxy in a cosmic dance that will reshape both galaxies. From the chaos of the Big Bang, order gradually emerged, forming galaxies full of stars. As we continue to study the universe, we're constantly learning more about how galaxies form and evolve and about our place within this vast cosmic tapestry. From galaxies to stars, let's delve deeper into the cosmic cradle. As the galaxies formed, within them, clouds of gas and dust started to collapse under their own gravitational pull. These areas, known as nebulae, were the birthplaces of stars. The dense, hot core of a nebula eventually ignited, giving birth to a star. These stars, in their varied sizes and colors, are the building blocks of galaxies, including our own Milky Way. Over time, the stars formed clusters, which then merged to create larger structures within the galaxies. But the birth of a star was not the end of the story. Around these young stars, clouds of leftover gas and dust started to swirl, forming a flat, rotating disk. Within this disk, solid particles collided and stuck together, gradually forming larger clumps. These clumps, or planetesimals, continued to grow, attracting more matter through their gravity. Over time, these planetesimals grew into protoplanets, and eventually the planets as we know them. This process of star and planet formation is a cosmic dance of dust, gas, and gravity, resulting in the diverse and complex universe we see today. So within galaxies, stars were born, and around these stars, planets were formed, setting the stage for the birth of our solar system. A subscribe button appears on the screen with a prompt. Enjoying the journey? Subscribe for more cosmic content. Among the billions of galaxies in a small corner of the Milky Way, our solar system took birth. Our tale begins with a seemingly ordinary cloud of gas and dust floating in the vast expanse of the Milky Way. This cloud, known as a nebula, was anything but ordinary. It was destined to become the birthplace of our solar system. In the heart of this nebula, something extraordinary started to happen. The particles of gas and dust began to collapse under their own gravitational pull, forming a dense, hot core. This was the birth of our Sun, a celestial body that would eventually hold the entire solar system in its gravitational grip. As the Sun continued to gather more and more matter, it grew hotter and denser, until one day, the pressure at its core reached such intensity that it triggered nuclear fusion, a process that releases an enormous amount of energy. This moment marked the true birth of our Sun, as it began to shine with the light and heat that we know so well today. But what about the rest of the solar system? Well, while the Sun was forming at the center of the nebula, the remaining dust and gas started to swirl around it, forming a flat, rotating disk. Within this disk, solid particles began to collide and stick together, gradually forming larger and larger clumps. These clumps, or planetesimals, continued to grow, attracting more and more matter through their gravity. Over time, these planetesimals grew into protoplanets, and eventually the planets as we know them. The inner planets like Earth and Mars were formed from the heavier elements, while the outer planets like Jupiter and Saturn were formed from the lighter gases. And so, our solar system, a family of 8 diverse planets revolving around a central star, was born. A unique and intricate cosmic ballet choreographed by the laws of physics and gravity. And thus around 4.6 billion years ago, our home in the cosmos was born. Fast forward to today, and the universe continues to expand and evolve. We find ourselves in an ever-changing cosmos, a vast expanse that refuses to stand still. The universe as we know it is not just a static collection of stars, planets, and galaxies. It's an intricate ballet of celestial bodies, each playing their part in a grand cosmic performance. In the grand scheme of things, our understanding of the universe has come a long way. With each passing day, modern astronomy peels back another layer of the cosmic onion. We've witnessed the birth and death of stars, charted the course of galaxies, and even caught glimpses of the elusive black holes. Yet, with every question answered, a dozen more arise, a testament to the boundless complexity of our universe. As we stand on the shoulders of the scientific giants who came before us, we've come to understand that the universe is expanding. This isn't just a gradual drift of galaxies away from each other. Imagine a balloon inflating, and on its surface are countless dots, each representing a galaxy. As the balloon inflates, the dots move farther apart. That's the universe for you, expanding in every direction, all the time. And it's not just expanding, it's accelerating. A mysterious force, known as dark energy, is pushing galaxies apart faster and faster. This invisible, yet incredibly powerful force makes up about 70% of the universe, yet we know very little about it. It's one of the greatest mysteries in modern astronomy, a puzzle that scientists are still trying to solve. But it's not just about what's out there. It's also about us, about our place in this vast cosmic stage. Every atom in our bodies was once part of a star. We are, in the most literal sense, stardust. We are a way for the universe to know itself, to understand itself. Even after billions of years, the universe continues its cosmic dance, full of mysteries waiting to be unraveled. So here's to the explorers, the dreamers, the scientists, and the stargazers. May we never lose our sense of wonder. The universe, from its fiery birth in the Big Bang to the present, is a tale of cosmic evolution, a tale that has been unfolding for over 13 billion years. We've journeyed together through this story, from the intense heat and energy of the Big Bang to the formation of galaxies, stars, and planets. In the aftermath of the Big Bang, the universe was a hot, dense sea of particles. Over time, these particles coalesced into atoms, and the force of gravity pulled these atoms together to form the first stars and galaxies. Our own solar system, a tiny part of the grand cosmic tapestry, was born from a cloud of gas and dust about 4.5 billion years ago. It has been evolving ever since, with life on Earth being just one small part of that story. Today, the universe continues to change and evolve. New stars are born, old stars die and become white dwarfs, neutron stars, or black holes. Galaxies collide and merge, and the universe continues to expand at an ever-increasing rate. As we gaze at the night sky, remember, we are not just in the universe, but the universe is within us. Until next time, keep wondering, keep exploring,